Today we're going to talk about truth tables. So let's just jump right on in, shall we? Truth tables are just a convenient way of organizing truth values of statements. Yesterday we talked about statements and compound statements and the negation of a statement, the conjunction of a statement, and the disjunction of a statement. So we're just going to put this in table form rather than just writing it out like we did yesterday. So for a negation, if we have our original statement and the negation of our statement, we can assume that our statement is either true or false. If our statement is true, the negation of our statement would be false. Similarly, if our original statement was false, the negation of that statement would be true. Let's go on to a conjunction. Now we have our two statements, P and Q, and we're going to state it as P and Q, so we're doing a conjunction. Since we have two statements that we're going to put in this table, we're going to start out with the original statement as being true, true, false, false. If we have two statements that we're comparing, we're always going to set it up in this similar fashion. True, true, false, false. And then for our second statement, we'll do true, false, true, false. This pattern is a good way to keep just organized, and when we're looking at these tomorrow or the next day, our conclusion is all going to be the same if we set our tables up the same. So let's think about what this conjunction means, P and Q. A conjunction, both statements have to be true. So if we look at this, if P is true and Q is true, then the junction of P and Q is also true. If the first statement is true and the second statement is false, well, then that conjunction would also be false because they both have to be true. In our next one, let's take a look. If the original statement is false and the second statement is true, well, our conjunction will also be false. And our last comparison will be false and false. Well, of course, that's going to mean that our conjunction is false. Let's look at a disjunction of those same two statements. Again, if you notice, we set our table up exactly the same. For the first statement, we said true, true, false, false. For the second statement, we're going to set it up as true, false, true, false. This time, though, instead of having a conjunction, we have a disjunction, which we use the term or. Now, if you remember from yesterday, in a disjunction, only one of these statements need to be true. So it'll be a true compound statement if both are true or if one are true. Either one is true. So let's look at this first one. This says if the first statement is true and the second statement is true, since only one has to be, well, definitely that's a true statement. Here, our first statement is true. Our second statement is false. Well, remember, it's a disjunction, so we only need one of them to be true. So this compound statement would be true. Again, if the first statement is false and the second statement is true, since it's a disjunction, our disjunction is also true. And if we look at our last possibility, we have both statements being false. Well, at least one of them needs to be true. So that would mean that this disjunction would be false. Let's go ahead and look at a couple more examples before we move on. In these tables, we're just comparing two things, but if you notice, we've got a statement P and we've got the negation of R. So when we set our table up, we're going to set it up as the original statement P, the original statement R, and then the negation of R. So we'll set our table up similarly. We're still going to go with, our first statement will be true, true, false, false. Our second statement is going to be true, false, true, false. Now for our negation of R, it's just going to be the opposite. Remember, the negation is the opposite. So if R is true, the negation of R would be false. If the R is false, the negation of R would be true. And similarly on these next two choices. Now let's take a look at our compound statement. Our compound statement says P or the negation of R. So, you might take your pencil and cover up this middle row because we don't need to look at it, and it's going to be confusing if we absently look at it instead of the first and the third column, which is what we're really considering. Remember, this is a disjunction, so only one of these need to be true. So on our first row, we have P is true and the negation of R is false, but that still makes our compound statement true. On the next row, both are true. The P is true and the negation of R is true. So that makes our compound statement true also. In the third row, we've got false and false. Well, in a disjunction, remember, it has to have at least one has to be true. So this is going to be false. And in our fourth row, we're looking and we have false and true. Well, that's going to make our disjunction true. This next table would work out similarly the same way. I want to jump down to this example down here because now we're comparing two negations. So we're going to start out like we did in this table here with P and R. So we're going to set up P here, R would be here, but we also need the negation of P and the negation of R. We're going to set our table up the exact same way for the first two statements. We'll go with true, true, false, false. And for our second statement, R, we'll go with true, false, true, and false. Now for our negations, remember negation just means the opposite. So if P is true, the negation of P would be false. And if P is false, the negation of P would be true. Now let's get our negation of R. If R is true, the negation of R would be false. If R is false, the negation of R would be true. So we can go ahead and finish filling in this table. Now let's take a look at what we're going to be comparing. Okay. This time we have a conjunction. We have a compound statement that's a conjunction. We have the negation of P and the negation of R. Remember, in a conjunction, both statements have to be true. So here we're comparing these last two columns, the third column and the fourth column. So we have false and false. Well, that's going to make our compound statement false. In the second one, we have the negation of P would be false, but the negation of R is true. But remember, this is connected by the word and. So that's going to make this false. Similarly, in the negation of P being true and the negation of R being false, again, we need both of them to be true for this to be a true statement. In our last row, we have true, true. So that's going to be the only statement, only case where this would be true. So that completes these tables. I'm going to take a break here because this is getting kind of lengthy, and we'll check back and I'll work a couple more examples for you.